8th grade. So we've made it to LP 36. We've made it to the end of our school year. We're going to be looking at 8th grade math packet for LP 36. It's the one that has this little letter on the front for you guys. Okay, so this is our final project of the year. This is also our final project of this last unit that has us learning about systems of equations. It has us solve by graphing and substitution and that sort of thing. So we are going to do a wrap up of that. Now, this project is going to look at the growth rate of two trees, and it's going to have us compare them. So this would be one way that we would use systems of equations in the real world to solve some sort of real world issue, okay? So if you go ahead and take a look at the first page, your first steps are to choose a tree, okay? So just a quick walkthrough, you're going to choose a tree. You are going to compare your tree with my tree, and we are going to write our equations. We are going to write, we are going to solve our equations, and then we are going to graph them. And then you're going to answer some questions about it and think about what it means as far as your tree, okay? Your very, very last piece is to put it together in a poster, okay, which we have paper in the back for you. So I'm going to walk you through, kind of look at how to gather this data, how to write it out, and then provide a couple of examples for that. So we are going to take a look at the internet real quick. Okay, so you can see I'm just on my Google Chrome, and I'm going to go to arborday.org. Okay. Now, to be able to find where you're going to pick a tree, I'm just going to follow the steps that I have written in your packet. We go to arborday.org. We choose trees. We choose choosing a tree. We go to the tree guide, and we browse the tree database. Okay. Now, at this point, it's going to pull up 357 possibilities for your tree. Okay. You can pick whatever tree in this list that you would like. I am going to work on with the shellbark hickory for this project. So you can pick any tree that is not the shellbark hickory, okay? So I click on it, it now pulls up a page that is all about my shellbark hickory tree, and it gives me all the information that I need, okay? So now I'm going to be looking at this page right here that says the life of trees at the top, okay? Our objective is to analyze systems of equations in the real world by researching the growth of a tree and writing an equation to represent that. We're going to determine when they are the same height, both algebraically and graphically, and we're going to kind of analyze our results, and we're going to look at them and see what we can learn. So 5 years ago, I planted a tree and I've tracked its growth. You decided that this year you want to plant a tree yourself and see when they're going to be the same height. So my tree is a shellbark hickory. You can see the name up at the top. To find its growth rate, I'm going to scroll down on this page, and it says my growth rate is slow. It's less than 12 inches per year. Okay, this paper says 10 inches per year. It's a slow rate. My mature size is right here. We can see the top mature size of my tree is about 80 feet, which is also written in the chart. So you are going to find your tree. You are going to write down this information in your chart, and that's going to sum up for part A. So I'm going to go ahead and get us off of here. We're going to take a look at the whiteboard, and we are going to kind of talk about how we go about setting up our equations then, just so you guys have some review. This is going to, once again, wrap up the things that we've been learning for the last couple of weeks. So remember, we did an assignment the other day that had us identify our variables. It had us decide what is independent and what is dependent here, okay? Remember that X is the independent variable. So this is the one that's going to happen, and it's going to continue, I-N-D-E-P-E-N-D-E-N-T, okay? It's going to continue, it's going to happen. It is going to work with or without the interference of the dependent variable. So Y is going to be our dependent variable, okay? So what we want to do is think about what two things are we actually talking about here. So for that, we're going to think about our original question. When will the trees be the same height? So at what time will the trees have the same height? Okay, so we're talking about time. And we're talking about height of the tree. And we need to figure out which one will be independent and which one will be dependent, okay? That's when we go back to our sentences. Does time depend, does the amount of time passed depend on the height of the tree? Or does the height of the tree depend on the number of years passing? Okay? Well, if we remember from the last video as well, we cannot control time. We can't go forwards, we can't go backwards, which means time has to be the independent variable. And the height of the tree is our dependent variable, okay? Now, we are going to work on writing these equations, okay? So, for that, I'm going to clear this out and I will be right back for us to start solving. So we're going to go back to my new whiteboard and we are going to first start filling out this bottom chart. We're still on this front page of it. We're down at this bottom chart right here where we start building our equations, okay? So we just decided that time is our independent variable and the height is our dependent variable for this, okay? So we are going to first think about our point. So for me, the y-intercept of my tree, the very beginning of my tree, I start at year 0. And I'm planting a seed. So when I bury my seed in the hole, it's completely flat. There's no height. There is nothing above the ground. So at time 0, my tree's height is 0, okay? So for my tree, the y-intercept and also the x-intercept is at this point. Now for your tree, I don't know, actually, you're planting a seed as well. So if you plant a seed, your tree also starts at a height of 0.
Hi, this is David with Xantran.
But your time is going to be different here, okay? I planted my tree at the beginning of this. That was 5 years ago. So if we call this year 5, then your time starts at 5. So this is the point that we are at, okay? The last portion of this is to figure out our slope. For me, I know that my tree grows 10 inches per year. So my slope is the rate of growth of my tree. So my slope is 10 inches for every 1 year. Okay? Remember, this is the y minus y. This is your x minus x. So the y values gave me the 10. It's going to grow 10 inches. And this 1 here is going to be my x for every 1 year that passes. Use your growth rate to figure out what your slope is going to be. Make sure you get that written into your equation, okay? Be back in just a second. We'll start figuring out how to write these equations.
Next time that happens.
Okay, so now we are going to take a look at writing our equation. Now, remember, we're going to be using our y equals mx plus b form here, okay? So in this case, this is my y-intercept. So that's my b. My slope is my m. So I can quickly just plug that in and say that y equals 10x plus, remember my b is the y value here, so it's going to be a 0. Now, be careful here because for my equation, I started with my y-intercept. You, however, are starting with the x-intercept. So this is going to take some algebra practice. You are going to have to plug in these values for the x and the y and solve to be able to find your b. This is something that we learned a few weeks ago. And as this is your final project, this is my chance to assess your abilities for that. Just remember, this is your X and this is your Y. So you're going to take and plug in whatever slope you got times that 5 plus B. Your goal is to solve for the B here so that you can write your equation in that form. Okay, that's going to be it for part A, and that's going to be it for the chart on part B. The rest of this is going to have you looking at the equations themselves and starting to substitute to solve, all right? The harder part here and the newer part is actually explaining what the solution here means. And I put there that I wanted you to use a complete sentence. Remember, we're looking for the time when the two trees have the same height. You're looking for that point of intersection if we were to graph it. So what does it mean in regards to our problem when you have found that point? Okay, that's what we're looking for here. Okay, there's graph paper on the back. You are supposed to label your graph on the x-axis and the y-axis. So what is the x representing? What is the y representing? We already talked about that earlier. You are going to use an appropriate scale. You're going to put numbers on your graph that fit. Okay, my tree may only have you go up to 100, but your tree may get really, really tall. So your trees may need a different scale. Think about how high you need to go to and write your numbers for the graph to match that. Okay, you're going to label the line. So when you graph the first line for my tree, call it tree 1. When you graph your line, call it tree 2. And write the solution point. So once you've found the point of intersection, draw a nice point on it and label with the x comma y point that you would need to describe as your answer. Here you can see there is graph paper available. Okay. Part D is results. It's going to have you actually look at what you've done and write up your findings as sentences, please, but as your data. So what is the height when they reach the same height? Does this seem realistic, right? So if you find out that the tree is supposed to be 150 feet tall and they don't get close, or if your numbers seem really weird, or if one tree is supposed to be going really, really slow and it's getting too tall faster than it should, that would be a good reason to look and see if maybe there was an error made or something else. Okay. Number 7 is going to have you think about what you know about trees and think about what you know about rates and slopes. And then number 8 wants you to actually determine what year your tree will be full sized, okay? Just says, remember to be careful to convert from feet to inches. Please make sure you read all of your directions carefully, as this may trip you up. The last part and the most fun part is you get to make a visual of your data, okay? So you are going to draw or print a picture of your tree. You are going to find out how much sun it needs. You're going to find out how much soil it needs. You're going to find out the wildlife value. So do a bunch of birds and squirrels eat from this tree? Does it help them? You know, what kind of things does it provide to the environment? And then the history of the tree, maybe where it comes from. Maybe it's a famous tree George Washington cut down. Who knows? But you can check that out. I left you 2 blank pieces of paper that you can use for your poster. Once again, you are welcome to print things. You can type up your data. You can handwrite it, make it colorful, make it beautiful, have fun with this, okay? And remember, if you have any questions, please make sure you reach out. I know that these are tricky and you did not have the best scenario to learn them in. Do the best that you can and please reach out to me. I want to make sure that you guys are successful, and this is our last project of the school year, so I want to make sure that you are doing your absolute best. All right? Great job, you guys.